So in this presentation, we're going to look at the box plots, median, quartiles, interquartile range, and box plots. So what we're going to do here first off is compute the median. So we have 26 UL students who are asked how many fizzy drinks they consume in a month, and the results are given below. And already we have them in numerical order, so we don't have to sort them. So the first thing we're going to notice is that the dataset size here is, let's pick a bit better pen than that. The dataset size there is n is equal to 26. So what is the middle pair of, this is an even number, that's something to pick up on. It's an even number size dataset. So the middle pair of values, get the average of those two, find the middle pair of values and get the average. Now the middle pair of values is the 13th and 14th element in the data set. So let's go through this here in ascending order. By the way, just a remark, it's in ascending order, it's in numerical order, so it's the 13th and 14th values as long as it's in ascending order. So if it's not in ascending order, you have to put it in ascending order. Anyway, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So the median is the average of these pair of numbers here. So it's 21 plus 25 over 2. That's 46 over 2. And that's equal to 23. Okay. The next thing we're going to do is find the quartiles. So a useful trick here is, in this particular case, is what we're going to do is we're going to divide the data set up into two halves. The upper half containing the high values and the lower half containing all the lower values. So what we're going to do is put a partition here. So the top row and the first 4 items there, that's the lower half of the data set, and those 5 numbers there, 25, 28, 35, 40, 50, and the bottom row, that's the upper half. Now, both halves have 13 elements, 13 members. Okay. So what we have to do is find the median of those. Q1 and Q3, the quartiles, are the medians of the upper and lower halves. So what we're going to do here is find the 7th element in each from the bottom of each. So 1, 2, 3, 4, 5, 6, 7. So that's the Q1 there. 1, 2, 3, 4, 5, 6, 7, 90. Okay, so Q1 is equal to 5 and Q3 is equal to 90. Okay, the next thing we're asked for is the interquartile range, and the interquartile range is simply the difference of those two numbers. It is Q3 minus Q1 and that's equal to 90 minus 5, and that's equal to 85. So the interquartile range is 85. So we have the first half of the question answered, this half here. What we have to do now is draw the box plot. Now we're going to use a lot of information we've learned already, but we have to find out 2 more important things. We have to find the lower fence, let's get the pen ready again, lower fence and upper fence. We have to compute these 2 numbers here. So we're going to do that in the next slide. Now, lower fence, we'll write it up here. Lower fence equals Q1 minus 1.5 times the interquartile range. Okay. Now, Q1 was 5 minus 1.5 times 85. That's equal to 5 times, let's put that in brackets, minus 127.5. That's a bit of calculator work. And that's equal to minus 122.75. That does not make any sense in the that does not make any sense in the context of this data set. what was the? Sorry, I just typed in the wrong number there. So that does not make any sense in the context of this data set. So what we're going to do is change it to 0. We can't have a negative. You can't drink a negative number of fizzy drinks in a month. So when a lower fence or something like that doesn't make sense, you can just change it to 0. The upper fence, UF, is calculated in a very similar way. Q3 plus 1.5 times the interquartile range. Now that is Q3 was 90. Plus, we have this value here from earlier on. We're going to use that one again. This time we're going to add it to the Q3, so 127.5, and that is 217.5. So that's the upper fence. Now, why do we calculate the upper and lower fence? What we're interested in is outliers. Are there any values less than 0 or greater than 217.5? Less than 0. Now, we know there's values there less than 0. That there are 0, but are there any values there less than 0? So there's no outliers on this side. There's no low outliers. There's none less than the lower fence. Are there any values greater than the upper fence? Are there any values in the data set greater than 217.5? No outliers on this side either. Okay, that's good. So there are no outliers in this data set at all. None in the lower half, none in the upper half. So we're ready to draw our box plot now. So we're going to do that now in the next slide. So first off, let's draw a number line. Let's put it in red here for a second. Just make sure I have a good pen. Okay, now this is the number line here. So let's just mark off Q1. I'm going to write this in green actually. You don't really write in your numbers onto the number line. The median was 23. Let's write that there. We're going to write it as Q2 because it's actually the second median. And Q3, let's put it up here as 90. So that is Q3. So what we do here now is we draw a box plot using these three values. So put a vertical line here, a vertical line here, and we join them up. Okay. Now, down where on the location of the number line where we have the median, we put a vertical line there through there. Okay. Now, just as a remark, you're not really supposed to see the red line there or the notation. It's just to aid the it's just to aid you when you're drawing it out. I'm going to rub them out now in a minute. The lowest value was 0. We put the lowest value at 0 because it was the minimum. Now, there are no outliers, so that's why we put it at the minimum value. So this is, let's say this is 0 here. And what we're going to do there is put the lower fence, or the bottom whisker. We call that a whisker, by the way. Let's write that in. This isn't the fence, this is a whisker. Actually the lower fence was there, but that's just beside the point. This is the lowest value in the data set that's not an outlier. So we're going to join that up there. Likewise, the highest value, the largest value in the data set that isn't an outlier was 196. So let's just say this is 196 up here. 196, let's say that's 196 there. That's where we draw the upper whisker. Okay. Now, just say for argument's sake that there was a point in the data set that was 220. Okay. Now, I know that changes all the other values. Just say for argument's sake everything just happened to stay the same. What would happen then? This is just to sort of demonstrate the whole point of whiskers. This is above this is the highest value, but it's an outlier. We would still draw the upper fence, or the upper whisker at 196, and what we would do is we would mark off 220 as an outlier, like with a little asterisk or a little circle. Now, that's grand. I'm just going to sort of tidy this up, just get rid of a bit of the superfluous notation. There we go. Well, I actually put in a bit of notation, but essentially your box plot should look like this. Oops, put that blue line back. Anyway, this is not part of the box plot this time, so we're going to get rid of that again. Alright, that is your box plot. Also, actually, the box plot is also known as box and whisker plot. And these are the whiskers there. Alright, that ends this presentation.